Hello, children. Welcome to another episode of Using Your Graphing Calculator in Pre-Calculus. So this lesson is going to cover finding exact extrema on your calculator, finding exact zeros using your graphing calculator, and finding solutions to any equation, regardless of whether you know how to solve it algebraically or you've ever seen it in your life. You can use your graphing calculator to help you with these things. So we're going to start with finding extrema on our calculator. So here is the function that we're going to look at, and I'm going to bring my calculator up here. And what you're going to do first is you're going to put the function into your y, onto your y screen here. Make sure that all of your plots are off and that you're not trying to graph anything else at the same time. That way the windows won't compete. So we have x cubed plus 2x squared minus 2x minus 1. Let's make sure that we have, oh yeah, see, I don't have that at all, do I? Let's just go back to the very beginning there. Try it again. X cubed, and I forgot to, yeah, it's just a little different. So x cubed plus 2x squared, make sure everything is going fine here now, minus, okay, good, 2x minus 1. All right, that looks good. So I'm going to hit graph and see if the window is appropriate. No, it looks like my window is just graphing the first quadrant. So I'm going to go to Zoom 6. Zoom 6 is the standard window. That's -10 to 10 in both directions. And that's a good place to go to just sort of orient yourself and see what the graph looks like. And lo and behold, everything appears in the screen here. Okay? There are 3 potential zeros when we have a cube function, and that's what we see. So there's no more going on with this graph. So we'll find the maximum and the minimum here. And this is what we're going to do. We're going to go to second calc. And it gives us the options value, 0, minimum, maximum, intersect. Well, if you look at the picture over here, this clearly looks like a relative maximum. So we're going to go down to maximum. We're going to hit enter, and it asks for the left bound. And basically it's saying when the x value is less than the minimum, so an x value that creates a y value that is smaller than the minimum, and on the left-hand side. So we're going to go to the left-hand side of our little bump here, okay, and hit enter. And then it says right bound, and so we're going to go over to the right. And then it asks for a guess, so we're going to go to the middle. I'm going to enter, and it tells me that the maximum is -1.7, comma 3.268. Okay, and that's a coordinate. Remember that the relative maximum is a coordinate. Okay, so we have that answer, and I'm going to let you guys find the answer for the relative minimum. You're going to do the same thing, but you're going to go back and you're going to do second calc, and this time you're going to go to minimum. And it asks you the same questions, left bound, which you could be right down here, and then right bound over here. I'm going to pause, and I'm going to let you do this on your own, and then I'll come back. Okay, so I hope what you found is that your relative maximum was -1.7, comma 3.3, and your relative minimum was 0.4, rounding to the nearest tenth, and -1.4, oops, my apologies, -1.4 is your relative minimum. Now, I'm going to just review a little bit. I'd like you to figure out what your intervals of increase and decrease are given this information. And again, pause the video, figure that out, and then start the video up again to see if you were right. Did you get it right? Well, I hope so. Okay, the next thing we're going to talk about is finding zeros of a function. Notice, just so that you could keep the same thing in your calculator, we're going to find zeros of the same function that we found our minimums and maximums. Okay, so here's my graph here. I'm gonna clear this out, and we'll start fresh. So we have the same graph. Obviously, you would enter that graph into your y equals like that. You'd hit graph, etc. You want to make sure that you find a window that holds everything that you think it should be holding. And this time we're going to go for that point there, and that point there, and that point there. I'm going to show you another little trick right now that is going to make this window a little easier to work with. You don't have to do this when you're finding zeros. This is just a trick. Hanji was asking about this, and it's a useful trick to sort of like blow up the graph just in the area you want to look at it. So in order to do that, we go to Zoom Box, and we take our little spider, and we cursor it basically over. We're going to make a new rectangle that's going to serve as sort of our window. And we're going to take it up to a corner up here. That's going to be our upper left corner. We're going to enter. We're going to drag it down. We're going to drag it over. And then we're going to hit enter. And now our window is just going to be focused on this smaller area here. It just gives us a little elbow room to work. So that's Zoom Box. That's just a little fancy trick there. So if we want to find this zero here, we're going to go to Second Calc again, and we're going to go down to 0 because we're looking for a 0. It's going to ask us for a left bound and a right bound again. So we're going to bring our spider basically to the x values that are to the left of this 0 and hit enter. And then guess what? It asks for a right bound, so we want to bring our spider to the right value. Basically, one of them has to be negative and one of them has to be positive if there's going to be a 0 there. And then we're going to take a guess. And there's our spider. Get a good guess. And so our guess here is negative 2.61. And then comma 0. So the coordinate of the 0 is negative 2.61 and 0. Okay? So I'd like you to use the same method here on your own and try to find this 0 and that 0. And again, I'll ask you to pause the video so that you can do that on your own. So here are the zeros. Negative 2.6, 0.38, and 1. Okay? Those are the x-intercepts. It's another word for zeros. We could say solutions too, or something. But I like zeros because zeros refer to when the function, the y values, are equal to 0. Excellent. The last thing we're going to talk about is how to solve equations. And I'm going to put the screen up just so that one piece doesn't distract you here. So I can actually solve equations. I'm paused. That would be such a bummer if I did that. Wow. Okay. I apologize. I'm not paused. That was embarrassing, but I'm going to keep going because I don't want to make this video again. Moving on, here we are at solving equations. There are two ways to solve an equation on your calculator. So this is a complicated equation. It's a cubic, and there actually is sort of a formula that's like the quadratic formula to solve cubics. But this, using your calculator is a foolproof way to solve equations when you need it to, and also to check your work if you've solved something algebraically and you want to know, did I do it right? So here's what you do. You go to your y equals, and I'm going to clear everything out. and I'm going to type in my two functions. I'm going to type in this into my y1 and this into my y2. So I'm going to type in x cubed plus 2x squared minus 2x minus 1, and then in y2 I'm going to type in 2x plus 1. And what I'm going to look for are the intersections. So let's graph it and see if we have a decent window. Well, okay, so I can see what's going to happen here. I think that the line is probably going to pass through this other part of the graph down here. So I'm going to expand my window again. I'm going to go to Zoom Standard, Zoom 6, and see if maybe this picture, if the graph is like this, we can fit it all in there. And we can. All right, so just remember what we're looking for here is x values that make this true. We want to know the x values that are going to make this side of the equation, y, equal to this side of the equation, y, y1, y2. But we're solving for x, we're not solving for y. So I'm going to go to, guess what, second calc, and I'm going to hit intersect. And this one's the easiest one. You move your spider, I'm going to move it closest to the point that I want. Notice there are 3 points of intersection, so I have to make sure that I tell the calculator which one I'm talking about. So it says first curve, and the spider's on the blue, and then I hit enter, and it says second curve. I'm just going to make sure that it's not, there we go, enter. So it's identified the two graphs, and now it says guess, so I'm going to put it on the point that I'm interested in. And it gives me -3 point, I can't quite read it, -3 point something or other. And y is -5.17. So it gives me those pieces of information there. And I'm only interested in the x value. I'm not interested in the y value because this equation has no y's in it. So that is one of my solutions. So why don't you pause again and figure out the next two zeros using this method, and then unpause when you want the answer. So there are the correct answers. Hope you got those. The next method is moving everything onto one side of the equation, so subtracting 2x plus 1 from both sides of the equation. So you get this on one side and 0 on the other. When you graph that, you're going to be looking for zeros, because we want to know what values of x will make the graph hit the x-axis. What values of x will make y equal to 0. Now you can pause the video and do this one on your own, and you should get these same answers. Notice that they're coordinates, but we don't care about the y values because we're not solving for y. We are solving for x. Okay, so that's an important distinction to understand when you're solving an equation. You have to understand what you're looking for. So the last part of the video is just practice. Okay, so here is your practice. You can find the extrema of this function. You can then find the zeros of that same function, so you can practice those two things. And then here is an equation that will allow you to practice both methods of solving equations on your graphing calculator. And you can pause the video and do that. And after you unpause, you can see the answers here. Okay? So I hope that went well for you. Hope you feel good about graphing, and you can review this as many times as you want, even if you understand it, just because you want to hear my voice. Over and out, kids.